Okay. Yeah, so I'm going to talk today about our in-season soil moisture mapping project. It's one of the projects that fits into Farming Smarter's field tested program, which is sort of focusing on taking compelling research results or interesting technologies and field testing them at a field scale. So this project in particular, what we wanted to do, we wanted to see if we could really understand how soil moisture behaves and changes throughout the season by mapping it with an EM38 in season, which isn't really the common use. Often the EM38, which is a tool that uses electromagnetic induction to measure soil conductivity. It's often used to measure salinity or soil moisture or soil texture sort of off season when there's no crop there. So we wanted to come in and see if we could improve on current soil moisture assessment techniques. Often there'll be a single or a couple of soil probes in a field, but they don't really give you a good sense for the spatial distribution of soil moisture and how it might change throughout the field with variability in soil texture, variability in rainfall, etc., etc. So yeah, we're pretty excited about the idea. So we've been mapping. We've got 2 fields, and we've been mapping them every 2 weeks throughout the season, sort of in crop, and we're fortunate. We found a couple of locations that lend themselves to be mapping sort of late season. This is probably not practical for a lot of fields. Our idea is to sort of be mapping early crop stage, but as you can see behind me, we've got a seed alfalfa field, so we've got bays mowed out for the pollinator tents, which is perfect for us to drive in and do our mapping kind of throughout the season. So kind of excited to be able to see how that soil moisture changes throughout the season, and how small of changes can we detect with the EM38. Can we detect variations in rainfall and a bunch of different things. So once we finish this year's study, so year 1 is really going to tell us a lot about how well the technology works. We're collecting soil samples at the same time. So does it accurately reflect changes in what's really happening in soil moisture throughout the field? And when we have a good handle on that, next year we'd like to use that technology to help make management decisions. So on one side, we're going to use that to say, can we use this information to better manage variable rate irrigation or to help us decide when and where to apply water? And the other possibility is using it for variable rate in-season nitrogen. So, often when we're doing nitrogen prescriptions for a field, especially on a variable nitrogen, we're using it based on yield projections that are based on pre-season estimates of what the yield's going to be. But if you think, a month into the season, a month after things have been seeded, whether it's been really rainy or really dry or how that field's held moisture, that might change those yield projections, and that might give us an opportunity to update rates of nitrogen. So that should be able to help us reduce nitrogen application. So we're sort of hedging our bets and applying nitrogen, based on a later assessment of soil moisture. So as we have a little more information to go on to sort of make those estimates. This field does have subsurface drip irrigation, and there's certainly a challenge for us collecting our soil samples. We've got to be careful not to hit the lines in there. But what's nice about it, this has been a pretty dry year. So our other site, it might be a little bit too dry to really get a sense for changing moisture. Ideally we'd be able to go in, map it, and then get 3 inches of rain and map it in 2 weeks and understand that change. And in a rain-fed environment, I'm not sure how much of that we're going to see. But the nice thing here is we know exactly what we're putting on. We know what the moisture, that the moisture is changing throughout the season. The water will get shut off at some point, so the seeds can fill out, and we'll map it again. So we know we're going to have changing moisture in here, which makes it a really nice environment for doing a study like this. That's kind of one of the advantages of the EM38. It's a pretty small unit. It's not very invasive. It's not very destructive. So it does give us the opportunity, when crops, even early spray timing kind of thing, 40, 50 days in, depending on the crop, we can get in there with the quad that's light, that's not causing big tire tracks. The EM38 doesn't touch the soil. It's a non-contact sensor. So yeah, so that's one of the nice things about it. We have the opportunity to, get in there in the crop without causing any damage. especially, May or June kind of thing. So.